Welcome back. You have now completed an entire week of machine learning basics. You just built your first predictive model, understood how machine learn, and even ran code successfully. This week, we will shift gears into something absolutely fundamental: data. There is a famous saying among data scientists: a model is only as good as the data you feed it. So, before we build smarter algorithms, we will learn how to understand, clean, and prepare our data. Think of week 2 as your data chef training, because before cooking, you must wash, chop, and prep your ingredients. So, what does data means? In machine learning, data is simply information, but arranged in a form that the computers can read. Every dataset has two essential parts: feature, which is the input variables or characteristics; labels, the target output we are trying to predict. You can imagine the features as questions and the labels as the answer. Suppose we are predicting the house price. Each feature might be size of the house, number of the bedroom, location, age of the building, and the label is price. The model's job is to learn the relationship between features and label so that when you give it to a new house, it predicts the price. Take a moment and think, what could be features and labels in your favorite app? Maybe in Spotify, features is genre, tempo, artist, and label would be how much you like it. That's how models learn your taste. So let's explore our dataset. Let's open a small dataset and see the features and labels in action. We will use Pandas, Python's powerful data handling library. You will see simple table appear. Each row is one data point. The first three columns, size, bedroom, and age, are features. The last column, price, is label. This is what we feed our ML model. Pause and observe. Which column describes the house? Which one are we trying to predict? Great. You have just identified the feature and label. Not all data looks like neat tables. Machine learning deals with two main types of data: structured and unstructured. Structured data is like a clean spreadsheet. Each column has meaning, whereas unstructured data is messier but richer, like think like a movie reviews or photos. Both kinds are important. Most beginner ML projects start with structured data because it's easier to manage, and that's what we'll focus on first. In practice, data comes in many formats. Let's learn the common ones you will handle as a data scientist. CSV, common value, most common; Excel, spreadsheet format; JSON, hierarchical text structure; SQL, stored in tables queried by SQL; images, audios, text, unstructured data format. Pandas can load nearly all of this with one line command. Don't worry about memorizing them, just recognize the names. Soon, loading data will feel as natural as opening a file. Before you start modeling, you must always look at your data first. This step is called exploratory data analysis or EDA. Let's learn a few pandas command that helps us peek inside. Dot head lets us glance at our data. Dot info tells us what kind of value each column holds, which is number, string, or missing entries. Dot describe gives quick statistic like average and ranges. This is how you get to know your data before you trust it. Think of it like meeting a new friend. You learn their background, habit before starting a project together. Data deserves the same curiosity. Here is something most beginners underestimate. Data cleaning can take up to 70% of project's time. That's because real world data often has missing values, duplicates, outliers, inconsistent text, or measurement units. We'll fix each of these in next lesson. But for now, just remember, messy data is equal to messy model. Have you ever worked with a messy Excel sheet? Maybe empty cells or spelling mistakes? That's exactly what we face in ML datasets too. The good news, you will soon know how to clean them efficiently. Data isn't just about numbers. It comes in two main types, and this affects how we pre-process it later. They are numerical and categorical. Numerical is quantitative value, which is height, price, age, and categorical is qualitative labels, which is city, color, and gender. Some columns might be even ordinal, categories with an order like low, medium, high. Knowing the data type helps us to decide what operation to apply. We can calculate averages on numerical data, but for categorical data, we may need to encode it into number. We'll cover this on day 3. Let's explore our own data. Let's do a little exploration. Copy this to your Colab or Jupyter notebook. This is a classic data set of restaurant tips. Each row represents one bill at a restaurant. The columns include total bill, the amount of bill, tip, the gratuity, sex, the servant's gender, day, time, and size of the table. Try running dfinfo and dfdescribe. See how Panda summarizes the data for you. Now identify which columns are numerical and which are categorical. So let's summarize today's key ideas. Data is the foundation of ML. It consists of features and labels. Structured data lives in tables. Unstructured data includes text, images, and audio. Understanding the data types shape how you pre-process them later. EDA helps you to see and trust your data set. For your practice, load the tips dataset again. Find the average total bill for each day using pandas. Plot the simple bar chart of tips by gender. That's the wrap up for today. You have just learned how to read and interpret the language of data. Tomorrow, we'll get our hands dirty, literally, with data cleaning. You will learn to fix missing values, remove duplicates, and polish raw data sets into modeling ready gems. Great work for today. See you soon.